Hello everyone, let's get ready for Lab 10. It's HTTP and it starts right now. Alright, here we are in 1.1, and there was a lot that we did before this 1.1 started, where we went through the process of using the requests module to go out and access this URL with the HTTP GET method. And then the response we got back is, you can look at it in raw format. And you'll notice if you look at it in raw format, it's in JavaScript object notation. So what we learned in the dictionaries unit is how to deserialize JSON data into a Python data structure. And we can do the same thing. There's a JSON method in the requests module, the response object of the request module, that will do the deserialization for us. And then once again, now in this particular instance, geodata is now a Python data structure. Okay, so down in 1.1, we're going to do exactly the same thing, but with a completely different API. So if you go here and click on this API, you can see that you get some data back here. And it's in JSON format, JavaScript object notation format. And what we're looking for is the name of the president, which is right here in this data structure here. So we want to do this programmatically in Python. I want to go to this URL, and then I want to print the president's name, which in this case is right here. All right, let's see if we can make it work. So you'll notice that the structure of doing this is always the same. Doesn't matter what URL you're going to, the code is eerily familiar, as I like to say. So the pattern is, we get a response from my requests get that URL. So when I go to that URL with the get method, I'm going to get a response, and then I can assume the response is okay, but I could also check. I could say if response is okay. I could do that, but I'm not going to. I'm going to just let it error out if the response is not okay. And what I'm going to do is I'm going to say data is response JSON. So, in these two lines of code, what do I have here? This does an HTTP GET to this URL, to whatever the URL is. And then this takes the HTTP response body and deserializes this to a Python object. It assumes the format is JSON. It assumes the format of the response is JSON. So I run this, and what I get back is a Python object. And this Python object is now, if I guess what I should do here is, let me run this and let me add another cell here. And I'll say, hey, what's the type of data? And it's going to say it's a dictionary. Okay, so we know a dictionary has keys, right? So I can say data keys. What are the keys here? And there's one key, meta, and another key, objects. Okay, so let's take a look at it again. There's a meta key, and then there's an objects key. Do you see the president's name under the meta key? I don't. So let's go to the objects key. The objects key is a list. See, it begins with a square bracket. You can also say, hey, what's the type of this objects key? And it says it's a list. Now, lists have values, right? So there could be more than one president in here, and that's why, excuse me, it's in a list. If you look, the first value in the list has the name of the president in it. So I'm just going to grab that first value from the list. And then now this is a dictionary. Let's take a look at the keys in this, .keys. And there's a caucus, current, description, end date, leadership, party, person. I don't see name in here, but I do see person. Let's go take a look at person. Person. And then in person, there is name. So I want to go get it. It's person. Then under person, it's name. Name. And there you go. Now you got the president's name. This is what we call walking the Python data structure. In this case, that data structure is a dictionary with a list in it, and then another dictionary, and then finally it gets down to the value. Okay, so that gets us the president's name. I could take that and say pres name is that, and then print pres name. And that's all we are going to do in 1.1. This whole code, every time I run it, it goes out to the internet, queries this URL, breaks up the response into a JavaScript object notation, breaks up the JavaScript object notation response into a Python data structure. Then I extract the data out of that data structure I want. That's basically what is happening here. Okay, that's 1.1. Okay, in 1.2, excuse me, we are using the GovTrack API, which allows us to retrieve information about people in government with one of 4 different roles: senator, representative, president, or vice president. For example, when you add role type equals president to the request URL, you get the president. When you add role type equals senator, you get back all the U.S. senators. Let's take a look. So we have in this code a list of the different roles, and then we're interacting on that role. So that's going to be our input. And then our main function is then going to go to GovTrack, use our role type, and then show us the data of people that fit in the role. Should be showing the names. Okay, let's run it. There's lots of errors in here we're going to have to fix. That's the whole point of the exercise. And a role type senator. Okay, representative. Okay, you notice as I switch these, the requested URL does not change. This is here for debugging purposes only. It's not really something you'd normally show in the application, but we're showing it here so that you can make sure that your URL that you're requesting is correct. Okay, so that role type is not changing. It says %3f. Let's see if we can fix that. So I have role type right there. I don't want to say question mark. I want to say the variable that holds the selected role type. And that variable is role_type. So that's what I want to put here. Like that. Okay, now the URL will change. It says senator, representative, see that? And then president. So I'm going to click on this president one. And then there's the data I get back. And you'll see it has an objects, and then it's a list of objects. And then again, I can grab their name out of here, right there. We did this before. Okay. So, where did we do that? It was up here. Right? We did objects, person, name. We're going to need something like this. Objects, person, name. All right. Let's go down here. Response, JSON. That should be a function like this, JSON. And then for item in data objects, that's the list. And then the person's name is going to be, I think it was, let's just do this. Let's just put name in here just for now. Okay. So there, senator, there's all there. It just says name. And if I go to president, I just get one because there's only one president, name. And then if I go to vice president, I get one because there's just one vice president. If I go to representatives, there's a whole bunch of representatives. Okay. I want to replace name with their actual name. So in here, I want to put, you know, each item in the loop is each representative, each president, each vice president. And then before, when I did this to get President Biden, it was person name, right? That's how I found it in the Python data structure. So that's the same place. See, the 0 is because I'm not looping over it. I'm just picking one out, but now I'm going to loop over it. So down here, I want to say item, person, name, like that. And that should probably do it. So there's all my senators. Okay. And let's pick a different request. Let's go with president. There's a president, vice president. There's a vice president. There's a representatives. There's a whole bunch of them. Okay. It seems to be working. Very cool. Very cool. So, in hindsight, what did I have to fix? I had to fix this role type. I had to make sure JSON gets called as a function, not like this, but as called like a function. And then I had to go grab the right item from that Python data structure, which was that list, right? And the response data has a key called objects, and then under objects is all of the senators or all of the representatives or all of the presidents, even though there's only one. And if I show you this, if I go to president, right, and I click on the link here, right, it says objects, and then there's a bracket, which is a list, but there's only one president. Okay. Then I go back, and let's pick senator. There's 100 senators, and I go click on here, and you'll see there's a object list, and you'll see here's one senator, here's another senator, here's another senator, here's another senator, and if I kept going, I'd find 100 senators. But every senator has a key called person, and then under that person they have a key called name. And that's what gets me each senator's name. And that's why this code here has person name in it, because it's pulling the same keys from that item, which is just one item in that list, which is data objects. Okay, so that's basically how 1.2 works. In 1.3, we're using a different API called the Text Processing API. And this API requires us to not use a get method, but requires us instead to use a post method. Now, why does it use a post method instead of a get method? Well, simply put, there is a limit. Oops, that's not coming up. There is a limit to how many things you can send over the get method. So when you want to send a lot of data, you have to use the post method, because it injects the data into the body of the text rather than on the URL. There's only the URLs can only be of a certain length. They cannot be very long. So this example up here sort of sums up what we need to do. And then down here, we're going to write, let me see if I can make this fit on the screen better. Down here, we're going to write something very similar. It says, use the example above to write a program which will input any text and print the sentiment using the same API. So this should be pretty easy to do. I'm just going to have some text, and rather than input it, I'm just going to put it right in here for now. I am very sad at the world today. I'm just going to put that in there. I'll change it to an input later once I know everything else works, rather than me constantly retyping in the input. And my URL is going to be this URL up here. This is the endpoint. This is the endpoint by which the web service will work. And then payload is a variable. You can call it anything you want, but this is what's sent in the body of a post request. So normally when you send a GET request, as you saw up here, when we do a GET request, we add these parameters, and then the parameters end up on the query string, which is this part of the URL. You can't put a paragraph of text excuse me, on the query string. It's too much text. It'll give you an error because the URL will be too long. So instead what we do is, along with the request of the URL, we send a payload in the body of the request. The body is not seen unless you're sniffing the network traffic. You will only see the URL if you're just logging what the activity is. Okay. So in the requirement of the body is it must have a key called text, and then the value is whatever text you want to send it. In this case, it's going to be the variable text. So whatever I type in here, that is going to get sent in the body. And then I'm going to make the request. This actually goes and does it. I'm going to do a post request, and the post request will take the URL, and then for the data, it's going to be my payload. Then I could take the response JSON, and when I deserialize that, I am going to get my sentiment data. And just for now, I'm going to print just the entire dictionary. And it says probability negative. So the label is negative, and the highest probability is that it's negative right there. All right. So maybe I want to print the sentiment label. Negative. And I'm going to show you a little trick because I've got your attention. Maybe I do. I don't know. So the label, the sentiment label is negative, and then negative, I could use the negative value as a key to retrieve the probability. So I can say sentiment label, and then sentiment label. This is going to give me the probability, because if the sentiment label is negative, then sentiment negative is 57%. Maybe, maybe not. Maybe I didn't pay attention close enough to what it was asking. Probability. Oh, it's under probability. So it's sentiment probability key. And then the key after that is label. Without all the extra brackets, Mike. There. So sentiment probability, and then because it's negative, I get the negative probability. So let me combine this all into one fancy print. Print with an F string. And we're going to print sentiment label. And then let's print. I'm not going to type that. Good Lord. I'm going to copy that. That colon dot to F. That'll get me. There we go. Negative 58%. Okay. And then I can get rid of these two. And then let's just print the original text back out. Okay. And then let's print in front of this, let's say sentiment. There. Okay. Now, let's make it more fun by putting a real input here. You know, I'm going to actually maybe use an interact, but I'll just use a regular input. And of course, let's go grab some from the internet. All right, after much searching, I found an article here about rhinos in Nepal. I don't know what it's about. I'm just going to copy it, and I'm going to go back to my program, and I'm going to paste it in here. It's a lot of text. Okay, and then it analyzes all that text, and it says the sentiment is neutral. Well, that was rather uninspiring. But see, that's a lot of text, right? So we can't possibly send all that on the URL. We have to send that in the body. Let's see if we can make something positive come out of it. Happy sunshine. Makes sunshine, makes me smile all over. All right, that's positive. Okay, so the sentiment analyzer seems to be working, and we're calling that API to do it. That's 1.3. Okay, in 1.4, we are tasked with rewriting this as a function. And one thing that students always ask questions about is this raise for status. Well, basically this is how it works. If the request works and you get a valid response, no error occurs. If you get a response code that's not a 200 series response, that is, it does not begin with a 2, this is the success error code. The 300s, the 400s, the 500s, those are not successful. So it will throw an error, throw an exception when you get a 400 or a 500 with response raised for status on. If you have response raised for status and you're not using this, then you have to check to make sure the response is okay. You can't make an assumption that your response worked. But if you add this response raised for status, you can, because it will throw an exception before you actually try to deserialize the response itself. That's what that raised for status does. Leave it out. It's your responsibility to check if the response is okay. Put it in here. You're guaranteed that it'll barf and throw an error when the response is not okay. You want it to barf and throw an error when the response is not okay, so that you know something happened that's out of your control. If you're getting a 400 error or a 500 error, then that means that there's a problem not with your Python code, but with this. It's not available to be requested. And I will demonstrate that right now. So if I put in like this, right, that's not a resource that we can go to. So we get a 404 client error, which says this is not found. See, there's nothing wrong with your Python code. It's that the resource you're requesting is not on the internet. If I go here and just, boop, not found. Okay, it's just not there. If I take out raise for status, okay, I get a JSON decode error on this line here. That gets me thinking, gosh, what did I do wrong here? Well, the problem is that you got a response. The response is, dude, I can't find what you're looking for. But then you chose to just try to decode it anyway into a Python data structure. That is the reason we want raise for status. We want it to barf up an error that says, hold on a second, the request didn't work, because it's not a 200, before we actually try to deserialize the response. If we don't do this, then we are responsible for doing the error handling, which means we have to say if response okay, then do this, right? And then else we need to do something else, like print something went wrong or whatever. See, this gets ugly and wordy rather quickly, and that's why the better way to approach it is to just throw the exception when the request doesn't work, and then you can figure out how to troubleshoot it from there only when you need to, right? Remember, exceptions are exceptional, and we only handle them when there's a need to handle them, right? So this is a matter of fixing our code, and then it works. Okay, now that we know that and the backstory makes a little more sense, let's write the function. So let's call it def IP lookup, and we're going to pass in as input nothing, because it's going to use your computer. It's going to look up the IP on your computer. And then we are going to pretty much do everything that we have in here. So we are going to use that URL, get the response, raise it for status, get the data, and then what we want to return back is just the key that gives us the IP address, which in this case is data origin. So we want to return data origin. And then we can test it. And we should get our IP right there. Okay? And it's the same IP we got up here, but now we wrote it as a function. Okay, that's it as far as HTTP goes in this lab. Have a good one. Bye now.